Hello students. Before I go any further, I just want to go over what I just did in that at the end of the last video there. So what did I actually compute here? Well, I noticed I had one permutation here and another permutation here, and I wanted to put them together. So what does that mean? Well, let's look at what the permutations are. The first permutation here switched these two. That's all it did. The next permutation did this. So we had blue, red, yellow. So what I wanted to know is what happens if you do both of them. So let's think about that. Let's put them in this order to start. I'm going to do both of them in a row. So first I'm going to do this, and then I'm going to do this. And notice that the red, which was in the first slot, went to the third slot. So we could say the first slot went to the third slot. The second slot stayed in the same place. Even though it moved around, it ends up in the exact same spot. And the third slot item went into the first slot. So what this is telling us is it's telling us what happens if you do one, then the other. So this is a composition, a process of doing one thing and then the other. Now, how should we write this computation if we're trying to talk about matrices like this? Well, one thing we could do is we could just write it as top to bottom. Like I'll say 1, 2, 3, 2, 1, 3, and then I'll say 1, 2, 3, 2, 3, 1. And then we can sort of follow. How did we do that? Well, I wanted to know where 1 goes, so I make a new matrix here, and I say, hey, 1 goes to 2, but 2 goes to 3, so 1 goes to 3. 2 goes to 1, and 1 goes to 2, so 2 goes to 2, and 3 goes to 3, which goes to 1. So that's how I got this answer. Now, I don't like this notation for a number of reasons. One, it's got extra information that I might not need. You could say, okay, well, what happens if we get rid of the top row and we just write where the things go in order? So instead of writing 1, 2, 3, 3, 2, 1, we could write this to represent that permutation. And yeah, we can do that, though we do have to be kind of careful when we do certain computations if we use this shorthand. It can be a little tricky to work with, or at least trickier than some other methods that we might want to come up with. Let's look at another method. So what's another thing that I could do if I wanted to write down this permutation and this permutation? The other idea that we might come up with, and this is something you could come up with sort of on your own, is you could just draw where they go. So, for instance, I have 3 spots, 3 slots here, 3 slots here. If I want to draw 1 going to 2, I could use arrows depicting motion, right? Things move along the arrows. So 1 goes to 2, 2 goes to 1, and 3 goes to 3. And if I wanted to draw this one, what I could do, 1, 2, 3, 2, 1, 2, 3. So here, 1 is going to 2, 2 is going to 3, and 3 is going to 1. So how could I compose these? If I wanted to do this first and then that, well, one thing I could do is I could just go straight across here, and I could look at the paths. See, 2 goes up and back down to 2. 1 goes down to 3, and 3 goes straight and then up to 1. So this is a very nice way of writing it visually. I mean, I find it pretty, and it's easy to keep track of where things are going, but it's a lot of drawing, like especially if I were to have a larger collection. Yeah, I might not want to do this if I brought in, I don't know, some more objects. Taking a yellow one and add a purple one. So, I mean, already I don't want to draw like 5 arrows every time. I don't know, maybe I'm being nitpicky. Maybe it's okay to draw 5 arrows. But it really isn't the easiest thing to compute with. And it has some extra information because I'm writing everything twice. So you might say, okay, what happens if I try to write everything once here, right? You didn't like it when we tried to only write what we needed there. Well, maybe this will be a little better. So instead of writing this, what's in this box, the way I did, one thing I could do is I could just have 1 dot for 1, 1 dot for 2, and 1 dot for 3. And I could say, okay, 1 goes to 2, 2 goes to 1, and 3 goes to itself. And for this one here, I could just draw 1 dot for 1, 1 dot for 2, and 1 dot for 3. So 1 goes to 2, 2 goes to 3, and 3 goes to 1. And I do like this a little better. I mean, I can certainly see sort of what's going on here in a way. For instance, if you told me that I applied this twice, so I'm going to do this twice, I'm going to do the same permutation twice, I can see immediately that everything goes to itself, because the 3 is going to bounce around here, the 1 is going to go back, the 2 is going to go back. So that's nice. If I write something in this type of notation, I might not see that so easily. Here I could see if I do this once, I'm not going to end up where I was. If I do this twice, I'm not going to end up where I was. But if I were to apply this 3 times in a row, then every element, wherever we start, is going to go back to itself. Now, one thing I could do in order to simplify this diagram a little bit is, instead of doing two arrows, I'm always also allowed to do this. That's a matter of taste. Some people might like this one, some people might like that one, but let's give names to these. So I'd call this arrow notation. Arrow notation. And I call this digraph notation for directed graph. Now you might say, okay, isn't this technically a directed graph? Yeah, but this one is not the same as this one, so we have to be careful, right? We're not identifying this vertex with this vertex, so there's something a little bit different here. Now, if you say, okay, I'm going to define this to be 1 and this to be 1 prime and 2 prime, 3 prime, then yeah, technically it's a directed graph as well. But we just want to be careful that we're not identifying the 2 1s. Like the 2 1s are not the same vertex in that arrow notation. They are here in the digraph notation. So this is very much a directed graph. I like this, but we can do even better than this. What don't I like about this? Well, it's now a little bit harder for us to compose these, right? If I want to know where 1 goes after I do this, then this, well, I have to follow 1 to 2 here, and then I have to pick up the 2 here and go down to the 3. To find out where 2 goes, I know 2 goes to 1 here, but I pick up here at 1, and that 1 goes back to 2. If I want to know where 3 goes to 3 here, but then I pick up here, and the 3 goes to 1. So I can still do the composition, but I think this is a little easier to compute with. Okay, so the idea is maybe there's another notation that will do a lot of stuff for us at once and won't be too hard to compute with. And this notation is, I guess, closest to this digraph notation. It's basically going to ask us to put the information of the arrows in a nice form. So instead of drawing this, what I could do is I could say, okay, I'm just going to say where things go. So 1 goes to 2, and 2 goes to 1. But instead of writing 1 twice, I'm just going to close parentheses to indicate there that I start over. So 1 goes to 2, 2 goes to 1, and 3 goes to itself. So that would be a way of writing this first permutation, whereas this permutation here, I could write as 1 goes to 2 goes to 3, and then I close parentheses to indicate that 3 goes to 1. So this is what I'm going to call cycle notation. And you know what? I could even make this a little simpler. If numbers go to themselves, I don't even have to write them. Like, I could just say any number that doesn't go to something else, I don't even bother writing it. So I could write this first one as 1, 2, and the second one as 1, 2, 3. Okay, so this is what I'm going to do in this situation. Now we have to look at lots of situations. This is one very, very tiny example, and we haven't even tried to do the product here. But let's try to see how would we do this. I don't know which one I want to write first yet, but let's say I want to do the 1, 2, and then the 1, 2, 3. Well, I could say, okay, 1 goes to 2, which goes to 3. So 1 goes to 3. Now 3 goes to itself here, but then goes to 1, so I close bracket. And 2 goes to 1, which goes back to 2. So I could write this, or I could even ignore it. I'm allowed to do that. Okay, so that's an example of cycle notation. This is the one we're going to stick with for a number of reasons. It's very useful, but we'll talk about its uses more in upcoming videos.